Okie dokie.
Okay, guys, let's go over these questions. So quick recap from yesterday, because this all kind of connects. These questions are all connected. So what we talked about yesterday was if a building, if you drop a rock off a building of height h, right? We talked about how, okay, just starting with our really basic the two formulas. There's two formulas we need to know, right? And those would be, final velocity is initial velocity plus acceleration times time, and also final position is initial position plus initial velocity times time plus 1/2 acceleration times time. So we derived those. Hopefully they make sense to you. We're going to just keep coming back to those, okay? But in this process, we'll be able to reuse some of the results. So it's kind of like an iterative process. So you derive a result, then you use the result again. So anyway, so what we talked about was, okay, this formula for this problem tells me that h is 1/2 gt squared, which means the time it takes to hit the ground is the square root of 2h over g, right? And then we also figured out that the final velocity, so the velocity down here, would have been, by plugging this t into that equation, so this would be 0 plus g times t, so replacing that with a g and that with this expression, we got this answer here. So is everyone still cool with that? Does that all make sense? Okay. Tepid nods. That's how you know. Okay, so 42. So 42 says that similar kind of question. The cannon's at ground level. It's pointed straight up. And the cannonball is launched into the air with an initial velocity of v. So you got to be a little careful here when you're using these letters. So a lot of times we use v naught to indicate initial velocity, but the way this question is worded, what symbol represents initial velocity now? Just a plain old v. So just got to make sure we're okay with that. Okay, so let's write the first question is, what's the cannonball's height as a function of time? Initial height is 0, so it'd be initial velocity times time minus 1/2 gt squared. That's all there is to it. There you go. All we did was we replaced the symbols in that formula with the relevant ones. So now again, this minus sign could be controversial. You might go, I want to say plus 1/2 gt squared, and then know that g is a negative number. Let's just all, for the purposes of this, just say, okay, let's say g is positive 9.8, so then I'd have a minus in there. Make our formulas nicer. So is everyone okay with that? Okay. B, write an equation for the time it takes the cannonball to reach its max height. I know someone got this one. It's a simple formula. Once you hear it, you'll be like height velocity. Exactly. What if we come back to this formula and say, oh, I just have to set this to 0. So if I go, so here's the answer to A. Okay. So for B, all I have to do is say, okay, well, how much time does it take? My initial velocity, we're calling that V. V minus GT. I'm just solving for T, right? So what's the answer? V divided by G. Let's think about that. Does that make intuitive sense? Here's how much velocity I have, right? I'm dividing that velocity by how much velocity I lose every second. How much velocity do I lose every second? Well, that's what G is. for a rising object at least. On the way down, g is interpreted as the amount of speed you're gaining every second. But it's just the amount you're subtracting away from your velocity every second, as long as it's being influenced by, well, it's a projectile, as long as gravity is the only thing influencing. Okay, so are we okay with that? Okay, so part C would be write an equation of the cannonball's maximum height in terms of V and G only. So eventually it's going to reach some max height. That makes sense to everyone? So what do you think I can do? If I know the time it takes to get there, and I have a function that tells me how high the ball is at any given time, plug it in. Very good. Now, that's not the only way to do it. I could also maybe make some argument about average velocity, perhaps. I'll show you that in a second. But let's just do it the simple way, which is just I have a result, right? I know that I have an equation that tells me how high the ball is. I have an equation that tells me when this event is happening. So just plug that in. So what happens? Let's see. You get H max is, so V times V over G minus 1/2 G, replace that T with a V over G. Okay, it's a little ugly. What does that make? V squared over G. Very good. I have a V squared, and I've got a G squared on bottom, but then there's a G. So what's going to be left over when this gets simplified? If anyone here is familiar with my affinity for banana, you would know the answer to this next simplification. Who knows the answer to this? What's that minus that? What do you get? One banana minus half a banana make half a banana. Have a banana, eat half the banana, you have half banana. So you see, thing minus half of that thing makes half of that thing. That's nice. There you go. Although I kind of like, I don't know, for some reason, I don't know why, it seems more aesthetically pleasing to have it written like V squared over 2G. I don't know why, but that looks nice. How do you feel about that? Oh, oopsies. Okie dokie. Okay. So let's just talk about, I know we're almost out of time here, but for 43, I want you guys to, I know you guys can do 43 on your own. You've seen this. It's almost the exact same question, just slightly different, okay? So for 43, you are, for A, you're solving for how much time does it take to reach the maximum height. So look for a substitution, right? Look for a substitution that will allow you to figure out how do I relate my time to this H value, okay? So like you have this, you know some expression for H max, you know the time, so look for a substitution there. For B, also think about the symmetry between this, an object going up to reach its max height versus dropping an object off a building. And when you drop an object off a building, it reaches a speed just before it hits the ground. There's a symmetry there. Anyway, try that. That can be your homework, I guess, is try to figure out that relationship. We can check our work tomorrow.